Are you able to view my presentation now? Yes, okay, fine. So we'll continue with POSA bin. I told you in integrated management of stored grains, a major thing which we have to keep in mind is the storage structure. Whatever be the structure in which we are storing the grains, it should be. Can you note down the criteria for the for a safe storage structure quickly, one by one in the chat box? What should be the critical parameters for an ideal storage structure? Rat proof, airtight, moisture proof, insect proof. Yes. So all these preconditions are followed in POSA bin developed in IRA by Dr. S. Pradhan. So that is uh, that POSA bin is a cheap structure, and we were discussing about POSA bin, and POSA bin is a double layered structure. POSA bin, it's a double walled, not double layered, it's double walled structure, and in between the two walls we have a film of polythene sheet of thickness 700 gauge. I am repeating, uh, POSA bin is a double walled structure, and between the two walls we have a film of polythene film of 700 gauge thickness. And the raw material for construction of this POSA bin is bricks. We use burned bricks as well as unburned bricks. Okay. Yesterday we were discussing about the construction of the platform and the construction of the wall. Just a minute. Okay. So this is the platform. In the platform, inner part of the platform we will construct with the unburned bricks, and the outer periphery of the platform we will construct with burned bricks. Chutta katta. So above that, I told you it is a double walled structure. Above the platform, we will lay a polythene sheet of 700 gauge thickness, and above that polythene sheet we will construct another platform, and that platform we construct it with unburned bricks. The top platform or we construct with the unburned bricks. I will tell how it becomes later. And then once the platform is erected, that means the foundation is laid, we will construct the side walls, all the four side walls. And the side walls, again it is layered. That means there are one outer wall and an inner wall, and in between what you see over here, that yellow coloration, that is nothing but the polythene sheet of 700 gauge thickness. And if I draw the platform over here, just a minute. So consider this as the platform. No, once more I will draw. So this is the inner platform. This is the outer platform or the base part. Then this is the polythene sheet, and here this part is with burned bricks, and this part is with unburned bricks. The top portion is also with unburned bricks. But one thing we should keep in mind is that it's not like this. It's the sheet will be continuing over like this. I will just draw it like this. So what they first we will uh, construct the uh, base platform. Above that we will lay the sheet. That sheet is a single sheet. It will be a bigger sheet, not the size of the platform itself. And then we will lay the outer platform over here above that sheet, and then we will construct the inner wall like this. Then we have the extra sheet running over here. That sheet will be folded over the inner wall, and then we will start constructing the outer wall. In the outer wall, what we will do is the base 45 centimeters of the outer wall. See, this base 45 centimeter of the outer wall will be constructed with burned bricks, and rest of that will be with unburned bricks. I will be repeating. So the base of the platform we will construct first, and the peripheral part of the platform we will construct with burnt bricks, rest with unburned bricks. Then we will lay the polythene sheet of 700 gauge thickness. That sheet will be a bigger sheet to cover the entire storage structure, and above that we will construct the inner platform, and the inner platform usually extends only up to this much, and then we construct the inner wall. Once the inner wall is constructed with unburned bricks, we will keep this plastic sheet over the inner platform, and then we will start the construction of outer wall. And the basal portion of this outer wall, especially the bottom 45 centimeter height, we will be constructing with burned bricks. So if you see that the entire peripheral part of the pusa bin will be constructed with up to 45 centimeter height, it will be constructed with burned bricks. Rest will be with unburned bricks. What is the reason for constructing the peripheral part and up to 45 centimeter high with burned bricks? What may be the reason? You can guess, you can have a wild guess. Burnt bricks are stronger, moisture, yes, moisture, it's not, no, burnt bricks are stronger, that I agree. Not moisture, no, it's not exactly moisture. But the clue is there in the first person who told burnt bricks are stronger. What Harsina was telling, it was burnt bricks are strong. Yes, rodents, yes. So if we construct bond bricks are stronger, so up to 45 centimeter if you are constructing, and the periphery if you are constructing with burned bricks, it will make the structure rodent proof. Somebody was telling about moisture proof. Which part of the structure makes it moisture proof as well as insect proof? So we made polythene sheet. Yes, polythene sheet. So the polythene sheet makes the structure insect proof. The brick construction itself makes it insect proof, but moisture proofing, that is mainly by keeping the structure covered with a single polythene sheet. And this is the way the structure is constructed. So hopefully you followed it, the basic idea behind the concept, because the diagram which I have given in the slide may not be that easy for you to understand. That's why I have drawn it over there. Is it clear? Shall I continue? Okay. If someone is not following, please come up. We will repeat it again. No issues. So this much we have uh, told. Platform outer will be burnt bricks, inner will be with the unburned bricks, polythene sheet above the base platform. Then another platform with unburned bricks will be constructed. It is a double wall structure with polythene filling sandwiched between the two walls. Inner wall we will construct with unburned bricks that we are told. Outer wall, lower part will be up to 45 centimeter will be with burned bricks and rest will be with unburned bricks. The dimension can vary. Though I have given a dimension, it's a normal dimension which is given. But if you have higher volume, we can slightly increase the size of the structure. Or if you have lesser quantity of grains to be stored, you can reduce the size of the structure depending upon your requirement. So usually the height is 1.8 meter, length is 1.6 meter, and breadth is 1.2 meter. So 1.8 into 1.6 into 1.2 meter, that is the usual dimension. So this is how it's step by step. See, the base platform is laid. Above that, the polythene sheet is laid over that. Then we have the second inner platform, and then we construct the this is step 4. Then it should be inner wall. Then uh, the inner wall is constructed. This is the top lid. Then we will cover it with the polythene sheet. Then outer wall is constructed. On the outer wall, only the basal 45 centimeter will be having uh, burned bricks. And you can see a slight opening over here. An opening is provided at the base to collect the grains. Here you can see. Here that opening is provided. Here you can see a slightly improved version of that, wherein the up to 45 centimeter we have plastered the structure. We have cement plastered it to make it more rodent proof, more solid structure, and this is the lid. So this is a simple structure where we can construct the storage structure based on locally available raw material. So that's one thing. Then this is not part of the syllabus, but still I wish to cover it up to the last batch. I have not covered it. Usually I cover it for PG students. Just listen to this, because these conventional structures are slowly, the FCI godowns and all are slowly moving over to a modern grain management system called as grain silos. In India, several parts, Food Corporation of India has constructed grain silos. Have you heard about the term silo? Has someone heard about the term silo? Yes, Arvind has. Okay. So I will show the picture, then you will have a slight understanding. So this is the picture of a silo. This is just like our godowns. The current FCA godowns can be considered as individual households, and these silos can be considered as apartment complexes. I am repeating, the current godowns can be considered as individual homes, just like we have in Kerala. Most of the homes are individual homes, and the silos can be considered as apartment complexes in cities and all, where we utilize the vertical space. In India, land is cheap. That is why we are constructed large number of godowns, and we are occupying the horizontal space. But where land is becoming more and more and land is becoming more and more costly, we have to think about vertical storage structures. So these are vertical storage structures. Just listen to me. So here, these are specially designed railway wagons. What these wagons are, this is meant only for transporting grains. So once the wagons reaches this part, can you see over here? This part, we can connect the bottom of the wagon into this structure, and from the bottom of the wagon, the grains will be pumped into the uh, silos. It's not bagged. The grains won't be bagged. Just like നമ്മുടെ conventional storage or our conventional storage structure, grains are bagged into individual bags of 50 kg weight. Here it's not so. Grains are loosely handled. So grains will be in bulk in the wagons. At this point, this But from the wagon, just like we are connecting a hose to a petrol tanker or a diesel tanker to unload petrol or diesel into a petrol pump, we will connect a pipe at the bottom of the wagon, and from that wagon, this loose grains will be pumped into the vertical silos, and it will be stored in bulk. And this is usually constructed with metal. Earlier we used to construct with concrete. Nowadays metal sheets are used. And once this grain, I told you this is called as head unit. This is just for your understanding. And with the help of conveyors, these grains can be transported over to any part of this silo. So if you want to store the grains in the silo number one, this from here there will be a conveyor which carries our grain over to this silo and will be emptied into this silo number one itself, so that we can manage. And one thing what the structure will do, when the grain is transported over through this conveyor, it will be screened. That means it will be sieved to remove any inert material, any broken grains, etc. So during this mechanical operation, only sound grains are stored. All other inert material, damaged grains, broken grains, etc. will be separated, and only good quality grains will be stored in this metal silo. And another advantage is that this metal silo, we can slightly vary the temperature. One thing I don't know whether it is available in our country, but abroad, they have pipings inside the silos. Inside the silo, we have a network of pipes, and through that network of pipes, we can pump in hot air. So if you want to control an insect infestation, they will pump in hot air, increase the temperature inside the silo, keep the temperature inside the silo for up to 45 or 50 degrees Celsius for prescribed amount of time. All the insect will get killed. So that is automatic. Insect management is automatic. Another thing is that it is completely airtight system. So the chances of insect infestation is extremely low, and we can install sensors in it. You all people are familiar with sensors now. It is sensors is there everywhere. If we install sensors over here, these sensors will detect the present increase in carbon dioxide. I told you, when there is insect infestation, there will be rapid increase in the level of carbon dioxide because of the respiratory process of the insects, and there will be a rapid decrease in the level of oxygen. So if we install a sensor for carbon dioxide, what will happen is that it will detect any abnormal increase in the carbon dioxide level. Yes, grains can also respire, but that respiration rate is accounted upon. So there will be a slow increase in carbon dioxide. If there is any drastic increase, the system will give us a warning that yes, there is an insect infestation. And one more thing is, since it is airtight, we can go for fumigation. Fumigation I will discuss in the later in the chemical control. So this is the modern storage structure. And if you want to transfer it to again, it can be easily loaded onto the wagons again for distribution. So slowly, India also is having this kind of silos, and Food Corporation of India has entered into an agreement with private companies under public-private partnership to construct silos. And most of the silos in India are constructed by Adani Group. You know Adani. Adani Wilmar is one of the major player in food grains. You might have seen Fortune brand, Fortune Oil and all. That brand is owned by Adani. So they are into food business also. So they have a lot of silos constructed in our country in association with Food Corporation of India. So this is just a nutshell about what is the advances which is happening in storage in our country. In abroad and all, if you tell about silos, that is a routine thing. Because last year when I visited Cornell University as part of the IRD program, we visited several farms, and in all the farms, irrespective of the size of the farms, the grains are stored in silos. Every farm will have a silo. and the size of the silo depends upon the size of the farm. If they have a bigger farm, they will have a bigger silo. If they have a small farm, they have a small silo. So silos are the most common storage structure abroad, but we still have not ventured fully into silos, but slowly we are also picking up. So by the time when you are into any job or something, 5 to 10 years after words, you will be seeing a lot of silos. Okay, so that is with respect to silo. I'm not going into the details. I'll just the capacity can vary. A single silo can store up to 25,000 tons. That is the capacity of it. Cleaning, drying operation, everything, sieves, everything is mechanical. We can monitor the temperature. We can automatically provide aeration, insect monitoring system, fumigation system, and transportation. That whole thing I told you. Okay. See, these are the bigger silos. This is how they operate. It over here, another picture. And we have completed preventive methods. Preventive methods, we have seen hygiene and sanitation. Then I will repeat once again, hygiene and sanitation, stacking of the grain, disinfestation of the storage container before stocking the grains, then legal method, providing aeration, and the use of storage structure, perfect storage structure. Then comes curative methods. Curative methods, we have several: ecological, mechanical, physical, cultural, botanical, chemical, biological, engineering, and several other methods. Seeing all this, don't worry, we have a lot to study. No, it is pretty easy. Several things which uh, we have studied will come up in the next slide. So it's not that a bit difficult. We can easily cover it. So we will see it one by one. Ecological methods, we have discussed it several times. The importance of temperature in storage, the importance of moisture content in storage, and the importance of oxygen content in storage. These are the three factors, critical factors affecting the development of an insect pest in storage. So if we can manipulate this storage temperature, the moisture content of the stored grains, or we can reduce the oxygen content in the grain, then we will be able to reduce insect infestation in storage. So the first one is storage temperature. As I told you, 25 to 35 degrees Celsius. It is favoring insect development. So if we can store grains below 15 degrees Celsius or above 40 degrees Celsius, we can reduce insect development. I told you about just now about the silos where we can keep a higher temperature. Then moisture content. Uh, then the grains which are meant for long-term storage. We have, if grains are meant for long-term storage, it is preferable to dry below 10% moisture. If the grain moisture content is below 10% moisture, it completely arrests insect development. But usually we dry it around 12% because drying below 10% is pretty difficult. So the usual grain moisture content at the time of storage preferable is 12 percentage. As the moisture content increases, the chances of deterioration also increases. Then modified atmospheric storage, wherein the silos, just I have described, that is a modified atmospheric storage, wherein we are keeping the grains in an airtight structure. So slowly, because of the respiratory process of the stored grain, as well as the respiration of the insects present in the stored grain, oxygen will be consumed and carbon dioxide level will increase. It is an airtight system. There won't be exchange of gases between the atmosphere. So all the oxygen will be consumed by during the respiratory process of grains as well as insects, and the carbon dioxide will be increasing because of the exhaling carbon dioxide from grains as well as insects. So this will create an atmosphere which is undesirable for insect development, which is not congenial for insect development. This is modified atmosphere storage. So different terms are given. So that is modified atmospheric storage. Somebody was discussing, someone was telling in the previous class they don't know controlled atmosphere and modified atmosphere storage. I will just brief it. You will study in post-harvest engineering and all. In controlled atmospheric storage, the concentration of each gas is constant throughout the storage period. Just an example, take a lace packet. In the lace packet, they will flush nitrogen into that packet. They will pump nitrogen air into that packet and they will seal that nitrogen packet. Just a minute. So the packet will be containing nitrogen and they can fix the concentration of nitrogen in each packet. And if they seal that in airtight packets, the concentration of nitrogen in that container will remain constant throughout. That means the concentration, the gas concentration, individual gas concentration remains constant throughout the storage period. That is controlled atmospheric storage. In modified atmosphere, it's not so. It's what I have discussed. During the storage time, if the concentration of gases can vary. This is just now I described. As the storage time increases, concentration of carbon dioxide increases and concentration of oxygen decreases. That means the gas concentration, it's not constant throughout the storage period. So that is modified atmospheric storage. Are you clear about the difference between controlled atmosphere and modified atmosphere storage? Yes, okay. Then coming to mechanical measures. In mechanical measures, that is the first thing is screening. Just നമ്മൾ ഇന്നലെയും പറഞ്ഞതാണ്. Whenever വീട്ടില് അരിയോ എന്തെങ്കിലും സാധനങ്ങളോ സൂക്ഷിക്കുന്നതിന് മുമ്പ് നമ്മൾ വാങ്ങിച്ചു കൊണ്ടുവന്നാൽ ആദ്യം ചെയ്യുന്നത് അതൊന്ന് ചേറി വൃത്തിയാക്കി broken, cracked grains, any undesirable material is removed and only sound grains are stored. That is nothing but a mechanical measure. It's called as screening. So that's what we discussed in the case of silo also. Before storing the grains, mechanically all the broken, cracked, damaged grains, inert material, everything is removed in order to prevent insect infestation. So we can go for regular screening. There are sieves which can sieve out the broken grains and only solid grains are stored. So mechanical devices are also the in our household also. നമ്മള് പുട്ടിനും ഒക്കെ പൊടിപ്പിച്ച് വീട്ടിൽ അരി പൊടിപ്പിച്ചുകൊണ്ട് വന്ന എന്താ ചെയ്യും, വീട്ടിലമ്മ അതൊന്ന് സീവ് ചെയ്തിട്ടാണ് അരിച്ചെടുത്ത് ആണ് എടുത്തു വെക്കുന്നത്. So that is that these are all part of mechanical measures. And there is a machine called as endoliter. This is a machine which we use to mechanically remove insect infested grains. I have only learned about this name for pretty long back. This name is there in textbooks. I haven't seen this machine anywhere. What they will do is, this is the structure. This is an electric motor. The grains will be fed over here and these grains will be rotated inside this at a speed. And once these grains are rotated, these grains will strike onto the walls of this machine. This machine is called as endoliter. So once the grains strike on the walls of this endoliter machine, those grains containing the insect, once they strikes on the walls of the machine, the insect will get killed. So this is meant for destroying internal feeding insects. So the speed will be adjusted in such a manner that it won't damage the grains. So once the motor is rotating, it should not damage the grain, but the insect which is residing inside the grains get killed once the grains strike on the walls of the structure. So this is called as endoliter. Just remember about this term endoliter, where the centrifugal force was used to kill the insects remaining inside the grain. So this is the mechanical measures. Among the mechanical measures, second method is grain protection devices. I think you might have studied this. TNAU insect probe trap, TNAU pitfall trap, TNAU two-in-one trap, UV light trap, etc. I think you must have seen in the first or second course, IPM course and all, different kinds of traps. If I show the pictures, then you will tell. I think you might just shown to yes. Yes, telling yes. So this is the one. If once you see the picture, you might be remembering it. This is a cylindrical tube-like structure with so many holes over it, and this is a conical collecting part of the trap. So this will be inserted into the grain, and the insect will move through these holes and it will be trapped inside this hole. So this will help in detection of insect infestation, whether the insect infestation is present inside the grain lot, or another ways it will help to collect the insects also. So because insects will move towards the grain, because inside the tube it is hollow. So the insect will move towards the grain, it will be collected at the bottom. It is mainly used for detection as well as management of Rhizoperta, Tribolium and Pseudophilus. Then TNAU pitfall trap, this is meant for trapping those insects which are moving over the grain surface. We won't be inserting it completely into the grain lot. This top surface of the trap will be aligned with the top surface of the grain, so that the insects moving over the grain surface, once it reaches over this trap, it will fall through the holes in the trap. This is called as TNAU pitfall trap. Then two-in-one trap, this is combined. The probe trap and pitfall trap is combined. So this part, the probe part will be inserted into the grain, and the top portion will be remaining at the top level of the grain. So we can collect both kind of grain insects, those which are moving over the grain surface and those which are remaining inside the grain lot. That is two-in-one trap. Then we have a UV light trap, that is nothing but a light trap. So we can go for certain insects, certain storage, not all storage insects are attracted towards light trap. So these are certain mechanical measures, screening, rain protection devices or different kinds of traps. Then we can go for physical control measures. In physical control measures, uh, we have discussed about heat treatment. We can increase the temperature for a short period at a high temperature 55 to 60 degrees Celsius for 10 to 20 minutes. Then insect will get killed. We can keep the commodities at low temperature, especially those commodities which are high value in nature, like spices, tea, etc. If we increase the temperature for spices, tea, etc., it will lead to the loss of volatiles present in the spices and tea. And this marketed based on the volatile content, based on the aroma. So if the aroma is lost, its value is lost. So spice, tea, etc., such high value products we store at extremely low temperature of minus 20 degrees Celsius for 24 hours. If you store at that temperature for 24 hours, that entire lot will get disinfested. Then we can easily export it. Then controlled atmosphere, modified atmosphere that we have discussed. Then there is another method called as mixing with inert dust. I will discuss with inert dust in the next slide. Then solar energy, that is nothing but drying the grains under sun. Irradiation also I will discuss in the upcoming slides. So heat treatment, that we can be high temperature or low temperature, that we have discussed. Controlled atmosphere and modified atmosphere, that we have discussed. Solar energy, you know. Inert dust and irradiation I will discuss. Inert dust, these are nothing but certain powder kind of thing. Especially I will cite the example as wood ash. Have you heard about the use of wood ash for pest management? ചാരം ഉപയോഗിച്ച് നമ്മുടെ അടുക്കളയിലെ ചാരം പ്രാണികളെ തുരത്താനായിട്ട് ക്രോപ്സിൽ യൂസ് ചെയ്യുന്നു എന്ന് കേട്ടിട്ടുണ്ടോ? Use of wood ash, yes, especially for cowpea aphids and all. That is because of this property, inert dust property. So wood ash, diatomaceous earth, paddy husk ash. Paddy husk ash is nothing but umi. നമ്മൾ മലയാളത്തിൽ പറഞ്ഞ the ash obtained after burning, paddy husk. and kaolin, lime, etc. So what this fine powder of this material will do is, one thing that will do is, it there's a very fine particles and it can block the spiracles of the insects and it will lead to asphyxiation. That you can understand. Have you has anyone tried broadcasting lime in the field, in paddy field or anywhere? Broadcasting lime, not that calcium carbonate, that is after നമ്മൾ നീറ്റ് ചെയ്തതിനു ശേഷം പൊടിയാക്കിയതിനു ശേഷം. Has someone tried it? You have several people who have rice cultivation at their home. You try it once. It is an extremely difficult task because these are extremely fine particles. Once you broadcast it in the field, especially in rice field, all these fine particles will enter into your nostrils, and it is an extremely suffocating experience. So that's the same thing happens to the insect also. If you are mixing this inert dust with the grain, it will cause asphyxiation or and block the spiracles of the insect. And these are highly abrasive in nature. That means it can cause damage to the cuticle of the insect. That means it can ചെറുതായിട്ട് പോറൽ ഉണ്ടാക്കാം. It can cause abrasions in the cuticle of the insects. Once the cuticle is damaged, especially in the wax layer of insect cuticle is damaged, what can occur? Because of the abrasions caused by inert dust on the cuticle, and if the wax layer of damage, it can lead to moisture loss. Yes. And once the moisture is lost, insect may not be able to survive. So that is one critical way by which inert dust act on insect. And one more thing is, these are highly hygroscopic in nature. Hygroscopic means it can absorb moisture from the body of the insect. And as I told you, it can lead to abrasion of the cuticle and insect die of desiccation because of the damage to the wax layer. And sometimes it can cause damage to the insects by ingestion of these are very fine microscopic particles. Once it gains entry into the insect body also along with the food material, again it can cause damage to the midgut and other digestive system parts. So these are the ways by which inert dust act on the insect. It can block the spiracles and cause asphyxiation. It can cause abrasions to the cuticle and it will lead to moisture loss because of the damage to the wax layer. It is hygroscopic in nature. It will absorb water from the insect body, and ingestion of dust. And in India, its application is not that accepted. Just now, one student, MSc student of Rosemary teacher, has just completed an MSc thesis on use of inert dust. Because one thing that holds back the use of inert dust in India is we don't permit mixing of anything with the grains. So we can't use inert dust in grains meant for human consumption. We can only mix those in the seeds. And what we have observed in the case of this MSc student's thesis was that it absorbs moisture from the grains also, and the grain germination is also affected. So that student, her name was Harshaprada. Harshaprada studied the germination and other seed parameters during different periods of storage. Though inert dust was perfectly alright in protecting the seeds from insect infestation, it affected the seed quality pretty quickly. Within 1 or 2 months, the seed lost its viability. So in India, its applicability is pretty limited, but abroad it is widely used, and in online also it is available. And in abroad it is allowed for mixing with the grains. And there are certain reports that some of these materials have carcinogenic effects, but several other materials does not have any adverse impact. So that all are permitted. In Amazon and all, it is available online. So for Harshaprada, we procured it from online. So once I searched it in Amazon for the next 1 week, I had if I open any website, I had an advertisement of this inert dust popping up everywhere. So this is common available in our country. I don't know what is the use of inert dust other than for pest management in our country. So these are chemically unreactive with low mammalian toxicity. But its thing is that it is effective under low humidity. Because if it is effective under high humidity, it is hygroscopic. It absorbs moisture from the atmosphere. It is not that effective if it is under high humid condition. And we have some commercial formulation, dry dye, dryicide, etc. That means trade names of this inertness. Then irradiation is gaining importance nowadays. You might, especially boys may know about Abin Shah. He was my student, just completed MSc now. He worked on ionizing radiation for the management of pulse beetle. So that is, he worked with gamma radiation. So gamma radiation for management of storage pest is an old technology. We were standardizing several parameters of that. And nowadays, non-ionizing radiation is also gaining importance. And one such non-ionizing radiation is microwave radiation. So for my next student, that is, you may know her, Shikha Raju. Shikha Raju, I have given microwave radiation for the management of storage pests. So this radiation is gaining, especially microwave radiation is gaining more and more importance nowadays. In gamma radiation, we mainly use the radiation source as cobalt 60, and it can penetrate into a depth of 20 to 50 centimeter in solid food. So one major difference between gamma radiation and microwave radiation is that gamma radiation has high penetration power, but microwave radiation doesn't have that penetration power as gamma radiation. You might have used microwave or reheating the food materials in your home. So, does it heat uniformly? Say, if you keep a food material in the microwave oven, then heat it. So, whether it heats uniformly, keep it for 30 seconds and take it out. Whether it heats up uniformly, I don't know. Okay. What usually we do is we take it out after 30 seconds, we will turn it up again, then again we will keep it, because usually only the top layer gets heated up initially, and if we keep it for a longer time, then only it penetrates deeper. So the penetration power is bit low with microwave. That is the disadvantage of microwave radiation. And for gamma radiation, gamma radiated grains are perfectly all right for human consumption. Up to International Atomic Energy Agency has prescribed a dose of 10 kilogray. That is the unit for radiation, gray, GY. Prescribed that up to 10 kilogram, it is safe for consumption. And in Abinsha study, we checked the protein content, carbohydrate content, etc., and the grain in the irradiated as well as unirradiated grains. And there was no change in the nutrient content because of irradiation. So that is with respect to, and normally we can go for a radiation of zero point 0.2 to 1 kilogram. Yes, we have found this dose to be effective against pulse beater also in our study also, so that it can be the usual dose for irradiating grains, but this dose may vary with different insects, because certain insects are more susceptible to radiation, but certain insects are more tolerant to radiation. So depending upon the insect, the dose may vary. And one more thing is that irradiation may not kill the insect instantly, but the advantage is that irradiation makes that insect infertile, sterile, so that its reproduction is affected. So that is the major advantage. Even though there are few insects present in the grain, the insect will may not be get killed, but its fecundity is affected, its fertility is affected. And even at an extremely low dose, we conducted the experiment at a dose of 20, 40, 60 grays, etc. Not kilogray, 20, 40 gray. And none of the irradiated insects were able to produce offspring at even at the lowest dose of 20 gray. So that means even at an extremely low dose, insects are not able to produce offspring. So that is one thing. And for seed purpose, we cannot go for irradiation because irradiation can affect the germination and it can also lead to mutation. So for varietal purpose, it's not that. You might have studied about mutation breeding. So that is about irradiation. Irradiation, remember about ionizing radiation, that is gamma rays, non-ionizing radiation, microwave radiation, and cobalt 60 is the radiation source, the radiation dose, and it causes sterility in insects. And among the cultural methods, we have discussed about splitting of pulses. That I think in the previous class we have discussed about splitting of pulses because whole pulses are damaged more by the pulse beetle compared to split pulses because it is a primary pest. Pulse beetle, it cannot damage broken grain. So if you are storing pulses for a longer time, go for storing in the dal. Then parboiling of paddy, it makes the grain lesser susceptible towards insect infestation. And there are varieties which are resisting insect infestation. Uh, 1 year back, I did a project with a MSc zoology student, and we screened several KU cowpea varieties for its susceptibility towards the pulse beetle. How pulse beetle infests different cowpea varieties, and surprisingly, there are few KU cowpea varieties which are not at all infested by pulse beetle. Pulse beetle doesn't prefer that grains at all. So that is one particular. There are certain resistant varieties for that. Then among the botanicals, neem is used. Traditionally, also neem leaves, dried neem leaves, was mixed along with the grain during storage to prevent insect infestation. Another way is to coat the grains with neem oil, but it is for human consumption. It's not that preferred because it will lead to bitterness of the grain. So for seed purpose, it can be used. For human consumption, what we can do is, especially for pulses, cowpea, green gram, chickpea, etc., coat the grains with any edible oil. It can be coconut oil, sunflower oil, gingerly oil, or any edible oil. You coat these pulses with any edible oil and store it. Pulse beetle won't be able to lay eggs over it because there is a thin film of oil over the grain surface. And as you have seen in the brookit, when we were describing about brookit, the brookit lays eggs on the surface of the grain. And if there is an oil coating over the grain surface, the brookit may not be able to lay eggs on the grain surface. Any edible oil you take, sunflower oil, gingerly oil, coconut oil, or anything, coat the grains thoroughly with the this edible oil, store it. We can avoid insect infestation, especially pulse beetle. Then several botanicals are found to have effect on storage pests such as currants, pongamia, nerium, ocimum, acorus, lantana. So many of these insects are having plant material are having insecticidal property. And I discussed about edible oil. One more thing you can write it down is that I forgot to mention it over here. Essential oils are gaining more and more importance. Can you name a few essential oil yielding plants, essential oil yielding crops? Have you studied in agronomy essential oil yielding crops? Sage, yes, sage is one. But common lemongrass, rosemary, yes, yes, lemongrass. So this essential oil in any aromatic plant, if we extract essential oil, it is having most of these essential oils are having insecticidal properties, and these essential oils are now widely exploited for pest management, especially in storage. I don't know whether you know the person. I have a PhD student now named Vaishak. boys may be remembering him. And Vaishak is working on essential oils now. So this is what essential oils is coming over here. I thought I forgot to mention it. It's from aromatic plant, mainly conifers. Conifers, you might be remembering eucalyptus and all. Rutaceae, that is from all the citrus family. Umbelliferae, Myrtaceae, Labiatae, all this kind. Citronella oil, eucalyptus oil, lemongrass oil. All these oils are having insecticidal property, contact toxicity, as well as fumigant action. And certain essential oils are having repellent and insect growth regulatory activity also. Essential oils are gaining more important compared to other botanicals, other plant material which we discussed earlier. Then biological control. With respect to biological control, I would like to have a caution in the use of biological control materials in storage. Use of parasitoids and predators is not at all successful in storage, because if you release a parasitoid or predator into a storage godown, the parasitoid and predator will remain in the grain. Any insect remaining in a grain is unacceptable for consumer. So it's not that a wise decision to release a parasitoid or predator into a storage godown for managing stored grain pests. Because if you are releasing an insect into the godown, that remaining the dead insect body parts of the parasitoids and predators will be remaining inside this grain. So it is not that advisable. But we can go for entomopathogens such as Bavaria, BT, viruses, etc. And among that, I discussed about the work done by Harsha Pradha and Seed Technology, and we found Bavaria is very effective in managing storage pests. So Bavaria is effective, BT, virus, etc. But one more thing, we have to whatever be the thing it has, we have to mix it with the grain. But in our country, our law does not permit anything to be mixed with grain. So for seed purpose only, we do all this kind of things. And coming to the last one, that is chemical method. In chemical method, I told you insecticides can be mixed only with seeds, not with the grains. And for grains, we can go only for surface treatment or back treatment. That means treatment of the walls, floors, or treatment of the back. So that is the then malathion. Among these, the only two recommended is malathion and deltamethrin. DDVP from next month onwards it won't be there, so avoid DDVP. Bifenthrin is a new chemical which had my work was on this chemical bifenthrin during my MSc. So, but it's not still approved by the government. So you can write only malathion and deltamethrin. We have discussed the dose and all in the previous disinfestation in the preventive method. And another major method for insect management in storage godown is use of fumigants. Fumigants are the most widely used chemical method for insect pest management in storage. We have several fumigants. Uh, do you know what is a fumigant? I think you might be. I think I taken that class for you. What is a fumigant? Fume producing, gas producing. Yes, produces smoke or fumes. So in the gaseous form, it enters into the insect and kills the insect. Do you have a class at 10, Aravind?
sir, ഉണ്ട്.
Aravind, Aravind കേട്ടില്ല.
ഉണ്ട് sir, class ഉണ്ട്.
Class ഉണ്ട്. Okay, then I will be stopping over here. Only one more slide, then we will continue in the next class. Okay, fine. Thank you. Okay.